what you just seen there was a uniform motion depicted by me, Joseph Young Smith. So the distance of that room was 9.9 meters. I know it looks kind of small, but trust me, you can fit a lot. It took me 5 seconds to get over there, and if we divide the distance by the time, we'll get the velocity, which is not 1.9 meters per second. Got graphs here showing the uniform motion. This one here is nice too, yeah. Go on up here, and we'll blam. Don't mind that word's up there. Alrighty, so here we got the accelerated motion. Distance is still 9.9 because it's the same room. Times 4 seconds. I'll start the video of me going across right now. Now, if you're back from the video, which you probably are, you can see that at 3 seconds I went slower, which means that I have to divide 9.9 by 3, because it only makes sense, which would come out to be 33 meters per second, which would be the second velocity, which means the first velocity would be 6.6 meters per second. Now, if you do the special thing called the acceleration formula, oh, that's pretty big, okay, which you divide the v to the t, the acceleration, which I got, which was negative 0.825. Here's the little fancy graph. I couldn't get the other one because I did not know how it worked. Okay, so, oh yeah, touchscreen. So keep on going down here, and we have my write-up. Okay, so for an accelerated motion graph, the line shown either has to speed up and slow down. In this case, I started at a velocity of 6.6 meters per second, and I slowed down. The second velocity turned to be 3.3 meters per second. With all this data, I could find the acceleration, which was negative 0.825. Now for the uniform motion graph, the velocity has to remain the same, which is a distance of 9.9 meters and a time of 5 seconds. I found a velocity which turned out to be 1.9 meters per second, or v. Now that conducts the Unit 1 physics. Hooray. Goodbye.